For the final lecture of Chapter 9, let's take a look at El Niño and La Niña. El Niño and La Niña describe two variations on a common theme. They describe situations that occur in the Pacific Ocean, but that have global repercussions. So El Niño describes a period when the trade winds weaken and the sea surface temperatures rise above average over the central and eastern portions of the Pacific. So it gets warmer along the coast of South America. It's a warm phase of this tropical atmospheric ocean interaction, and we get areas of very heavy rainfall that shift from the western Pacific to central tropical Pacific. With La Niña, the trade winds become exceptionally strong, and the sea surface temperatures drop in central and eastern Pacific Ocean. So we call this the cold phase of the tropical atmospheric ocean interaction. So both El Niño and La Niña have global influences on the weather. We'll see how it affects the United States and other places around the world, particularly in wintertime, northern hemisphere winter. The weather extremes that accompany El Niño are kind of opposite of those that accompany La Niña. So we think of El Niño and La Niña as kind of a yin and yang situation. They go together, but they're opposites. Little background. El Niño is the name that's given to this phenomenon because it was first observed in Peru along the coast. Fishing is very popular there. And there's a cold water current that runs up the coast of South America by Peru. It's a very cold current right off the coast. And that cold water is nutrient rich, and so it allows for an abundant fishing economy. Well, in El Niño years, the fishermen observed there was something different. The water, instead of it being cold, was warm. And those nutrients that feed the fish were no longer there, and so the fish were not spawning. The fishermen were not able to catch as many fish. They noticed this happening around Christmas time, and in Peru and South America the predominant religion is Catholicism, and they call the Christ child El Niño, which is the boy, but at that time of the year when you hear El Niño it refers to baby Jesus, and so they named this phenomenon El Niño. So that is the way we describe the phenomenon, as El Niño. When we look at atmospherically what's going on, we've observed an oscillation or kind of a flip-flop of pressure, atmospheric pressure, in response to the flip-flop of sea surface temperatures. So the pressure flip-flop is called southern oscillation. And when we put El Niño and southern oscillation together, it's often just called ENSO, E-N-S-O, and it describes this whole phenomenon. So scientists don't know what causes ENSO, but we can describe it. We are still learning the different effects that are connected to this phenomenon that we call El Niño, and that's part of what we'll look at here. So normal conditions in the Pacific Ocean look like this. We have our trade winds that are converging around the equator at the intertropical convergence zone. So you see our trade winds in the flow of the surface ocean currents. So because all of the sort of warm tropical air and sea water that's been heated by the sun is being pushed to the west, we end up with warmer water kind of piling up over here in the Indonesia area, and low pressure associated with that. So warm water, moist air, there's instability, the air wants to rise, so we have low pressure over here. Meanwhile, on the other side of the Pacific Ocean, on the eastern side of the Pacific Ocean, because all the warm water and air has kind of been pushed to the west, it allows for this cool water that is encouraged by this cold Humboldt current. The ocean current that runs along South America is called the Humboldt current. So it's cold, it's coming from the South Pole. It allows it to upwell, to come up to the surface. So we get this strong Peruvian current with cool water and abundant fishing because of all the nutrients that come up here. So this is normal, and you can see up here in North America what we've talked about already in this chapter with our polar jet stream and the subtropical jet. During an ENSO event, particularly the El Nino phase of the ENSO, we have the opposite thing happening. So we have weakened trade winds. For some reason, they don't blow as strong, and we get this kind of pushing of warm water in the opposite direction. So instead of having all the warm water accumulate over in this portion of the Pacific Ocean, it builds up over in this side, where it's normally cool water, right? The upwelling from the Humboldt current. We now have warm water. So this is where it was first recognized because of the effect on the fish industry. And we also have corresponding pressure changes. So now this is warm. We're going to see lower pressure over in this portion of the Pacific Ocean and higher pressure over here. So it tends to dry things out over here and make things very too much rain, flooding conditions over here. And you can see that it affects the weather that drives weather for us in the United States. So we have a subtropical jet, wetter than average winter, so a lot of snow, and warmer than average winter in the northern part of the western and central United States. We'll talk more about this in a moment. You'll see these graphs in the book that show the same kind of thing happening. So it's a little harder to read, I think, but the brown blobs here are supposed to be continents. So here's the North American and then the South American continent. So in normal conditions, here are those trade winds and the predominant flow of wind and ocean currents on the surface of the ocean. So we get that warm water pooling over here in the western part of the Pacific Ocean with the associated low pressure, so instability, all that warm moist air rises, and we end up with this convective circulation current. This is a normal year. Notice also there's always discussion of the thermocline when we talk about ENSO events. The thermocline is basically a temperature profile of what's happening down below in the ocean temperature. So if we look deep into the ocean and see what's happening, because all the warm water is here on the surface, it pushes the colder water lower and lower into the ocean. But over here on South America, we have this upwelling of the cold, lower ocean water. So this is normal. We get that nice nutrient-rich water coming up in the western coast of South America. During El Nino years, we have this reversal. So the trade winds weaken, and the sea surface currents are pushing the water towards South America to the west, or sorry, to the east. And that causes this flip-flop in the pressure system. So instead of having the low pressure over here in the western portion of the Pacific, it's more central. And so we get very stormy conditions where normally we had dry conditions. And then we can see our thermocline has deepened. So the cold water is not upwelling up at the surface, but it's staying lower down in the ocean. During the La Nina phase, which is when the trade winds are stronger. So El Nino, the trade winds weaken. During La Nina, the trade winds are stronger than usual. So we get an even more vigorous push of warm water over to the western portion of the Pacific Ocean. And we have our low pressure and very strong thermocline. This thermocline is much more pronounced than it was in the El Nino picture, and upwelling of the cold water. So those are the three situations: normal, and then El Nino and La Nina. La Nina is the feminine of El Nino. If you don't speak Spanish, it means the girl child, and it was just kind of a cute name that was given to the opposite influence of what we observed with El Nino. The Galapagos Islands are just off the coast of Ecuador, so right around the equator, and there we have monitored the sea level, the depth of the sea level, and you can see here the normal, 0, and then variations from that normal. So when we have all that warm water that is kind of piling up along the coast of South America during an El Nino event, it causes the sea to be a bit deeper. So these spikes here where you see deeper than average sea depths are El Nino years. And then when we have the opposite thing happening, when the winds are blowing away from South America and, you know, pulling the water away from and allowing the colder water to upwell, we have lower than average sea depths at the Galapagos, and these would be the La Nina years. So when we look at the southern oscillation, it's the flip-flop of pressure that's measured between two locations, one in Tahiti and one in Australia, in a town called Darwin. Those are the two locations that climatologists have agreed to look at to determine an index called the Southern Oscillation Index that tells something about what's going on with pressure. So if there's an anomaly, we can know that it's likely to be an El Nino year. So here we see the Southern Oscillation Index. So we have standardized anomalies. So this is just showing how far from normal. So if we think of the zero line as normal, we have year across the x-axis. We can kind of see what's going on with the Southern Oscillation, the flip-flop in the pressure, when we look at what's going on with pressures in the Pacific Ocean, and the corresponding El Nino years. So we see here the monthly mean sea level pressure anomalies. So we have the spikes and the low points. When it's a strong positive, we have La Nina years. So they're blue because La Nina is associated with the cold phase of El Nino La Nina. And when it's a strong negative, we have El Nino. And here's the Southern Oscillation Index, which does a pretty good job of measuring, you know, what's going on with El Nino and La Nina. Here we have the frequency of these events. How often do they occur? So in this graph, we have time across the x-axis going from 1950 up to 2010, and departures from normal. And this is a multivariate INSO index. Instead of just the Southern Oscillation, which is one variable that climatologists use to study El Nino, we can take multiple variables into effect. So yeah, the pressure flip-flop that's embodied by Southern Oscillation, but also sea surface temperatures and other conditions that have been observed to be a part of El Nino. And we can see years when El Nino has occurred and then years when La Nina has occurred. So you see it happens regularly but not predictably. So it's typically between every 3 to 7 years that we have an El Nino event. And it's hard to predict. All we're doing is really observing conditions and calling it that way without knowing really what's driving this, what's causing El Nino. It makes it very difficult to predict. But once we see that the pattern is in place, we have a statistical track record of what to expect in terms of weather disruptions in different parts of the world. And here are two graphs that show weather disruptions around the world because of El Nino. So what we have here is El Nino conditions and the relationships with weather that's happening around the world, December through February, and then June through August. So December through February, of course, is winter in the northern hemisphere. So when it's an El Nino year and it's winter time for us in the United States, you can see that we're probably going to have wetter than average temperatures in the southern part of our country, and warmer than average temperatures kind of up here, part of our country, part of Canada, and then in the northeast as well. But you can see there are effects all around the world. And then if we look at what's happening in June through August in our summertime, we have wetter conditions than normal in the western U.S., but you can see the effects are worldwide. So looking at the coast of South America, during an El Nino winter for us, it would be summer for them, they have wet and warm conditions. And then during the June through August, their winter conditions, they have warm conditions. If we look at La Nina, just the opposite, we would kind of expect the opposite things to happen. So you can look at this graph and get a sense of what's going on with weather in the United States during the La Nina phase. It's just the opposite. Now we have dry and warm conditions in the southern part of the country, and cooler and wetter conditions in the northern parts and up into Canada. And then during June through August phase of La Nina, we can see again what's going on here. I'll just draw your attention to the Victoria area of Australia, where it's in the news often, where they have tremendous flooding during these La Nina phases. Here's a schematic from the book for El Nino in the United States, how it affects our weather. So we have these warmer sea level temperatures that are coming this way towards South America, and they kind of make their way up the coast of Mexico and affect the subtropical jet. And so we might see an increase in hurricane development down here in the tropical area of the Pacific, which can come up and affect weather for us in the United States. We also are likely to see flooding along the coast, the Pacific coast. So California, when you hear about all those mudslides and floods that happen, they often happen during an El Nino year. And we have flooding also in Northeast, and you can see just the general influence that El Nino has